Hello, in this lecture we'll find out the area of a circle using two different methods. In the drawing we have a circle and this is square ABCD. You know that this is line segment AP, that is equals to 1 unit in its length. This is line segment QC, that is equals to 3 units. And our mission is to find out the area of this circle. So we start with the first method. First of all the angles inside this square ABCD are right angles. So those 4 angles, they are all right angles. So this is a right angle. This is also a right angle. This is a right angle. And finally, this is a right angle. In the next step, we will define the center of this circle. This point is point O. And we will define the point of tendency of tangent AB. This is tangent AB with this circle. This point is point S. In the next step, we will join points O and S together by a straight line. Point O is the center of the circle, point S is the point of the circle itself, therefore OS is the radius of this circle. So we define the radius of this circle as x. So OS equals to x, according to our definition, it is the radius of the circle. So here we can implement rule 1. So I'll repeat quickly on rule 1. According to rule 1, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. So in the drawing we have a circle, and this is tangent AB, that is tangent to this circle at point M. Point M is the point of tendency of tangent AB with this circle. In addition, we have the radius OM, that is equals to R. The radius OM is drawn to point M, that is the point of tendency of tangent AB with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius MO. If AB is perpendicular to MO, it means that this angle equals to 90 degrees and this angle also equals to 90 degrees according to this rule, rule 1. So you can actually implement rule 1 in our drawing. In our drawing, we have the radius OS that is equal to x. The radius OS is drawn to point S, that is the point of tendency of tangent AB with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular. Tangent AB will be perpendicular to the radius SO. If AB is perpendicular to SO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. Likewise, we join points O and Q together by a straight line. Line segment OQ is of course the radius of this circle, is equals to x according to our definition. Here we can implement again rule 1, because we have the radius OQ that is equal to x. The radius OQ is drawn to point Q, that is the point of tendency of the BC with this circle. And whenever your radius that is drawn to the point of tendency, then tangent BC will be perpendicular to the radius QO. If BC is perpendicular to QO, it means that this angle equals to 90 degrees. And this angle also equals to 90 degrees according to the same rule, rule 1. So by doing these constructions, we can do quadrilateral SOQB. Inside this quadrilateral SOQB, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus the size of this fourth angle In total, they must be equal to 360 degrees according to the rule that states that the sum of the angles in any quadrilateral is equal to 360 degrees, and therefore these four pieces again must be equal to 90 degrees in its size. So inside quadrilateral SOQB we have 4 rectangles. And according to rule 5, any quadrilateral that has 4 rectangles must be at least a rectangle, not a square. So in relation to this quadrilateral SOQB, it's a rectangle because it has 4 rectangles. But we also know that the opposite sides of a rectangle are equal to each other. So in rectangle SOQB, side SO must be equal to the opposite side QB. But SO is x, therefore QB must be also equal to x units in its length. According to the same rule, in the same rectangle SOQB, side OQ must be equal to the opposite side SB. But as OQ is x, therefore SB must be also equal to x units in its length. So, we actually found out that quadrilateral SOQB is not a rectangle but a square, because all of its sides are equal to each other. Inside of this square SOQB is the length of each side of this square SOQB is x units. So we know that all the sides of square ABCD are equal to each other. That is to say, side AB equals to side BC equals to side CD equals to side DA. And especially side AB equals to side BC. So I write it down. In square ABCD, side AB equals to side BC. Side AB equals to AS plus SB. And it is equal to side BC. Side BC in total equals to BQ plus QC. BC equals to BQ plus QC. So according to equation 1, we should find out that AS plus SB equals to BQ plus QC. AS is the missing side, so we leave it as it is. Plus SB. SB equals to x. And it is equal to BQ. BQ also equals to x. Plus QC. QC equals to 3 units in its length according to what is given in the question. So in total, according to equation 1, we should find out that AS plus x equals to x plus 3. Here we subtract x from this equation, equation 1. And finally get that according to this equation, equation 1. So x will get cancelled. And we have to only with AS. That is equal to 3 units in its length. So I should find out that the length of the missing line segment AS is 3 units. So I write it down in the drawing. This is line segment AS that is equal to 3 units in its length. In the next step, we will do a construction. That is to say, from this point P, we will draw perpendicular on the radius SO. Again, from point P, we will draw perpendicular on the radius SO. So actually, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point P, this point P, and the radius SO, this point is point N. So actually, by doing this construction, representative, the small quadrangle APNS. Inside this small quadrangle APNS, we have 1, 2, 3 rectangles. The sum of 3 rectangles is 270 degrees. So 270 degrees plus the size of this fourth missing again. In total, it must be equal to 360 degrees according to the rule that says that the sum of the angles in any quadrangle is equal to 360 degrees. And therefore, this fourth missing again, must be equal to 90 degrees in its size. In order to complete the sum of the angles inside this quadrangle APNS, this missing fourth angle must be equal to 90 degrees in its size. So inside quadrangle APNS, we have 4 right angles, and according to all 5 and quadrangle that has 4 right angles must be this right angle and not a square. So we relate to this small quadrangle APNS as a rectangle because it has 4 right angles. So this is quadrangle APNS, it is a rectangle according to all 5. But we also know that the opposite sides of a rectangle are equal to each other. So a rectangle AP and S, side AP must be equal to the opposite side NS. Again, in rectangle AP and S, side AP must be equal to the opposite side NS. But AP is 1, therefore NS must be also equal to 1 unit in its length. Likewise, according to the same rule, in the same small rectangle AP and S, side AS must be equal to the opposite side PN. But AS is 3, therefore PN must be also equal to 3 units in its length. What is the length of this missing line 7, NO? From the drawing it is very easy to see that NO equals to SO minus SN. Again, NO equals to SO minus SN. So that is known, NO equals to SO minus SN. So NO in total equals to SO. SO is the radius of the circle that is equal to X minus SN. SN equals to 1, so in total NO equals to X minus 1 units in its length. So this is line 7 NO that is equal to X minus 1 units in its length. In the next step, we join points P and O together by a straight line. So point O is the center of the circle, point P is the point of the circle itself. Therefore, PO is the radius of this circle that is equal to X. In the next step, I'll copy this green right triangle P and O in a new page, and we will implement the Pythagoras theorem on this right green triangle P and O. According to the Pythagoras theorem, in any right triangle, the square of their product equals to the sum of the squares of the perpendiculars. So, I copy this right triangle P and O in a new page, and we will implement the Pythagoras theorem on this green right triangle P and O. Here by PT is the abbreviation for Pythagoras theorem. So actually this is the again right triangle PNO that I copied from the original drawing according to the Pythagoras theorem. In this right triangle PNO, PO squared, that is the square of the hypotenuse, equals to PN squared plus NO squared. So I write it down. PO squared, that is the square of the hypotenuse, is equal to Pn squared plus NO squared. The length of the hypotenuse PO is x, therefore PO squared is x squared. And it is equal to Pn squared. Pn is 3, therefore Pn squared is 3 squared, that is 9, plus NO squared. NO is x minus 1, therefore NO squared is x minus 1 squared. So x squared equals to 9 plus x minus 1 squared. X minus 1 squared equals to x squared plus 1 squared, that is 1, plus 2 times x times 1, that is minus 2x. So here we have x squared on both sides of the equation, so x squared gets cancelled. Now we cancel x squared, and this side of the equation is left with nothing, that is to say 0. On the other side of the equation, we left with 9 plus 1, that is 10, plus 2x. So in total, we found out that 0 equals to 10 plus 2x. Here, we add 2x to this equation, and we get that 2x equals to 10. Here we divide this equation by 2, and finally we get that x equals to 10 over 2, that is 5. So actually, the length of the hypotenuse PO that equals to x is 5 units. X is also the radius of this circle, so from now the radius of this circle, x equals to 5 units in its length. Our mission is to find out the area of this circle. So actually the area of any circle is equal to pi times the radius of the circle squared. Again, the area of any circle equals to pi times the radius of the circle squared, and therefore the area of our circle must be equal to pi times the radius of our circle squared. So, and the radius of our circle is x, so it is, and the radius squared is x squared, so it is pi x squared. The area of our circle equals to pi x squared. So it is pi times x squared. X is 5, therefore x squared is 5 squared. So in total, we found out that the area of our circle equals to pi times 5 squared. 5 squared is 25, so in total this expression equals to 25 pi. 25 pi is 78.54 square units. So if we found out that the area of this circle equals to either 25 pi square units, so in terms of numbers, the area of this circle equals to 78.54 square units. So finish with the first method. In the next step, I will present to you how to find out the area of this circle according to the second method. So first of all, A, B, C, D is a square, therefore all of its 4 angles are right angles. So those 4 angles are all right angles. So this is a right angle. This is a right angle. This is a right angle. And this is also a right angle. In the next step, we define the center of this circle. This point is point O. We define the point of tendency of this is tangent AB with this circle. This point is point S. In the next step, we focus on this convex point, point B. On this convex point B, we have two tangents to this circle, tangent BS and tangent BQ. And according to rule 2, they are equal to each other. This is to say BS equals to BQ. So I repeat quickly on rule 2. According to rule 2, the lengths of two tangents from a convex point to a circle are equal. So in the drawing, we have a circle. This is the convex point P. From this convex point P, we have two tangents to this circle, tangent PA and tangent PB. And according to this rule 2, they are equal to each other. That is to say the length of this tangent PA is equal to the length of this tangent PB. So PA equals to PB according to this rule 2. So can I implement rule 2 in our drawing? Why? Because in our drawing, as I already mentioned before, this is the convex point B. From this convex point B, we have two tangents to this circle, tangent BS and tangent BQ. And according to rule 2, they are equal to each other. That is to say, BS equals to BQ. So I write it down. The length of tangent BS is equal to the length of tangent BQ according to rule 2. So if we define the length of this tangent BS as x, then the length of this tangent BQ must be also equal to x because they are equal to each other according to rule 2. So we know that all the sides of this square ABCD are equal to each other. That is to say, AB equals to BC equals to CD equals to DA. And especially side AB equals to side BC. So I write it down. We did this process in the first method, but I have to repeat on this process in order to find out the length of this line segment AS. Okay, so in square ABCD, side AB equals to side BC. Side AB equals to side BC. AB equals to AS plus SB. AB equals to AS plus SB. And it is equals to BC. BC equals to BQ plus QC. BC equals to BQ plus QC. AS is the missing side, so we leave it as it is. Plus SB. SB equals to X. And it is equal to BQ. BQ also equals to X. Plus QC. QC equals to 3 units in its length, according to what is given as the question. So in total, according to equation 1, we shall find out that AS plus X equals to X plus 3. Here we subtract X from this equation 1, and finding out that according to this equation 1, X will get cancelled, and we left only with AS. Left only with AS that is equal to 3 units in its length. Exactly as we found in the first method. Actually, the length of this line segment AS is 3 units. In the next step, we'll extend line segment AD or side AD by a straight line until it touches the circle at this point. And we define the touching point of the extended line segment AD with this circle. This point is point N. In the next step, we'll focus on this common external point, point A. Point A is an external point in relation to this circle because of the fact that point A is not located inside this circle, nor all the circle itself, but it is located outside of this circle. Therefore, point A is defined as a common external point in relation to this circle. It is a common point to this straight line AB, and it is also a common point to this straight line AD. So from this common external point, point A, we have tangent AS, and from the same common external point, point A, if we draw a straight line, it will cut the circle at 2 points, point P and point M. In this way, we create chord PM. So in conclusion, from the same common external point, point A, we have tangent AS, and we have also chord PM. Therefore, we can implement here rule 10. According to rule 10, in any circle, if AB is any chord in the circle and PT is a tangent to the circle, then PT squared equals to PA times PB. So from this common external point, point P, we have here tangent PT that is tangent to this circle at point C. In addition, from the same common external point, point P, if we draw a straight line, it will cut the circle at 2 points, A and B. So from the same common external point, point A, so by cutting the circle at 2 points A and B, we created here chord AB. So from the same common external point, point P, we have here chord AB and also have here tangent PT. So in this drawing, the following equation is true, that PT squared equals to PA times PB. Again, PT squared equals to PA times PB. So we can implement rule 10 in our drawing. Why? Because in our drawing, as I already mentioned before, for this common external point, point A, we have here tangent AS, and from the same common external point, point A, if we draw a straight line, we cut the circle at 2 points, P and M, and therefore we created here tangent P, we have created here chord PM. So all the requirements of rule 10 are satisfied, and therefore we can implement here rule 10. According to rule 10, the following equation is true, that AS squared equals to AP times AM. Again, AS squared equals to AP times AM. So I'll write it down. So if we focus on the common external point, point A, according to rule 10, the following equation will be true. That AS squared equals to AP times AM. AS squared equals to AP times AM. AS is 3, therefore AS squared is 3 squared, that is 9. And it is equal to AP. AP is 1 times AM. AM in total equals to AP plus PM. Again, AM in total equals to AP plus PM. So we found out that according to rule 10, 9 equals to 1 times AP plus PM. So 9 equals to Actually, when you multiply anything by 1, it will not change the value of the expression that you multiply. So you can ignore in 1 and we get that this equation is 9 equals to AP plus PM. Because we ignore 1 and it will become 9 equals to AP plus PM. 9 equals to AP plus PM. So 9 equals to AP is 1 plus PM. 9 equals to 1 plus PM. Here we subtract 1 from this equation. And finally get that PM equals to 9 minus 1 is 8. So actually found out that the length of this chord PM, is 8 units. In the next step, we will do a construction. That is to say, from this point O, that is the center of the circle, we will go perpendicular on chord PM. Again, from point O, we will go perpendicular on chord PM. So actually, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point O, and this chord PM, this point is point N. So actually, we drew perpendicular ON from the center of the circle, that is to say from point O, we draw perpendicular on chord PM. Therefore, we can implement here rule 11. Whenever you draw from the center of the circle perpendicular towards any chord, you can implement rule 11. According to rule 11, the perpendicular to a chord drawn from the center of the circle bisects the chord. So in the drawing, we have a circle. This is point O, that is the center of the circle. From point O, that is the center of the circle, we draw perpendicular OM on chord AB. Again, we draw from point O, that is the center of the circle, we draw perpendicular OM on chord AB. So clearly, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. And according to this rule 11, perpendicular OM, that is drawn from the center of this circle, that is to say from point O, bisects chord AB. Okay? The perpendicular that is drawn from the center of the circle bisects the chord. The perpendicular that is drawn from the center of the circle towards any chord bisects the chord. Here, perpendicular OM, that is drawn from point O, that is the center of the circle, bisects chord AB. If perpendicular OM bisects chord AB, it means that perpendicular OM divides chord AB into two halves. Each half equals to AB over 2. So the first half is MB, that is equals to AB over 2. The second half is AM, that is also equals to AB over 2. So in conclusion, we found out that perpendicular OM divides chord AB into two halves. The first half is AM, the second half is MB, of course equal to each other, and each half equals to AB over 2. So AM equals to MB equals to AB over 2. We can definitely implement rule 11 in our drawing. Why? Because in our drawing, we draw perpendicular ON from point O, that is the center of the circle, on chord PM. So all the requirements of rule 11 are satisfied. and therefore can implement rule 11. According to rule 11, perpendicular ON bisects chord PM. Again, perpendicular ON bisects chord PM. That is to say, perpendicular ON divides chord PM into two halves. Each half equals to PM over 2. So the first half is PN, that is equal to PM over 2. The second half is NM, that is also equal to PM over 2. So I write it down. So according to rule 11, perpendicular ON, that is one from point O, that is the center of the circle, towards chord PN bisects chord PN. That is to say, it divides chord PM into two halves. Each half equals to PM over 2. So the first half is PN, and it is of course equals to the second half, that is NM, and each half equals to PM over 2. And again, perpendicular ON, that is one from point O, that is the center of the circle, bisects chord PM. That is to say, it divides chord PM into two halves. Each half equals to PM over 2. So the first half is PN, and it is equals to the second half, that is NM, and each half equals to PM over 2. But PM is 8. Therefore, PM over 2 is 8 over 2, that is 4. And from this long equation, we derive that Pn equals to 4 units in its length. Pn equals to 4. Okay. This is 97 Pn, that is 1 to 4 units in its length, according to rule 11. In the next step, we join points O and S together by a straight line. Point O is the center of the circle, point S is the point of the circle itself, therefore OS is the radius of this circle. OS is the radius of the circle. Because of the fact that the radius OS is drawn to point S, that is the point of tendency of tangent AB with this circle, whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius FO. If AB is perpendicular to SO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. So, by doing this construction, we actually get the idea. Quadrangle ANOS. Inside this quadrangle ANOS, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus the size of this fourth missing angle. In total, they must be equal to 360 degrees, according to the rule that states that the sum of the angles in any quadrangle is equal to 360 degrees. And therefore, this fourth missing angle must be equal to 90 degrees in its size. So inside quadrangle ANOS, we have 4 right angles. And according to rule 5, any quadrangle that has 4 right angles must be this right angle is not a square. So we write to this quadrangle ANOS is right angle. It's a right angle because it has 4 right angles. So quadrangle ANOS is a right angle according to rule 5. But we also know that the opposite sides of a rectangle are equal to each other. So in rectangle ANOS, side AN must be equal to the opposite side OS. But AN is 1 plus 4, that is 5. Therefore OS must be also equal to 5 units in its length. But OS is the radius of the circle, and therefore the radius of this circle equals to 5 units in its length. our mission is to find out the area of this circle. Actually, the area of any circle is equal to pi times the radius of the circle squared. Repeat again, the area of any circle equals to pi times the radius of the circle squared. And therefore the area of our circle must be equal to pi times the radius of our circle squared. The radius of our circle is 5, and therefore the radius squared is 5 squared. So in total, we found out that the radius of our circle must be equal to pi times 5 squared. 5 squared is 25, and therefore in total this expression is equal to 25 pi. 25 pi is 78.54 square units. So actually, in both methods, we found out that the area of this circle is equal to either 25 pi square units, or in terms of numbers, the area of this circle equals to 78.54 square units. Okay, so finish with the second method. In the next step, I will summarize the lecture. We'll start with the first method, of course. In this lecture, we found out the area of this circle using two different methods. So in the drawing, we have a circle. This is square ABCD. You know that this is line segment AP, that is equal to 1 unit in its length. This is line segment QC, that is equal to 4 units in its length. Again, our mission is to find out the area of this circle. So first of all, we know that all those 4 angles inside square ABCD are right angles. In the next step, we define the center of this circle. This point is point O. We define the point of tendency of this tangent AB with this circle. This point is point S. In the next step, we join points O and S together on side line. OS is the radius of this circle. We define the radius of this circle as x. So OS equals to x. The radius of S is on to point S, that is the point of tendency of tangent AB with this circle. And whenever you have a radius that is on to the point of tendency, then tangent AB will be perpendicular to the radius SO. If AB is perpendicular to SO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. Likewise, we join points O and Q together by side line. Point Q is the point of tendency of tangent BC with this circle. OQ is of course the radius of this circle, that is equal to x. The radius of Q is down to point Q, that is the point of tendency of the tangent BC with this circle. And whenever you have a radius that is on to the point of tendency, then tangent BC will be perpendicular to the radius QO. If BC is perpendicular to QO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to the same rule, rule 1. By doing these constructions, we get the quadrangle SOQB. Inside this quadrangle SOQB, we have 1, 2, 3 angles. The sum of 3 angles is 270 degrees. So 270 degrees plus the size of this 4 pieces angle, in total it must be equal to 360 degrees according to the rule that states that the sum of the angles in any quadrangle is equal to 360 degrees. And therefore this 4 pieces angle must be equal to 90 degrees in its size. So inside the small quadrangle SOQB, we have 4 right angles. And according to rule 5, any quadrangle that has 4 right angles must be its inside angle not a square. So we relate to this quadrangle SOQB as a rectangle because it has 4 right angles. But we know that the opposite sides of a rectangle are equal to each other. So in rectangle SOQB, side SO must be equal to the opposite side QB. But SO is x, therefore QB must be also equal to x units in its length. Likewise, according to the same rule, in the same rectangle SOQB, side OQ must be equal to the opposite side SB. But OQ is x, therefore QB, OQ is x, therefore SB must be also equal to x units in its length. So actually found out that quadrilateral SOQB is not a rectangle but a square. Why? Because of the fact that all of its sides are equal to each other. Each side of this square SOQB equals to the length of each side is equal to x units. So therefore, quadrilateral SOQB is a square. We know that in square ABCD, all of its sides are equal to each other, and especially side AB equals to side BC. So repeat again, in square ABCD, side AB equals to side BC. AB in total equals to AS plus SB, and AB equals to AS plus SB, and it is equals to BC. BC in total equals to BQ plus QC. Again, BC equals to BQ plus QC. So in total, according to equation 1, we found out that AS plus SB equals to BQ plus QC. AS is the missing side, so we leave it as it is, plus SB. SB is x, and it is equals to BQ. BQ is also x, plus QC, that is 3. So in total, according to equation 1, we found out that AS plus x equals to x plus 3. Here we subtract x from this equation, so x we can cancel, and we left only with AS that is equal to 3 units in its length. So this is the missing answer, and AS is equal to 3 units in its length. In the next step, we did the construction, that is to say from this point P, we do perpendicular on the radius SO. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point P and the radius SO, this point is point N. By doing this construction, we can get quadrilateral AP and S. Inside the small quadrilateral AP and S, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus the size of this 4 facing angle, in total must be equal to 360 degrees, according to the rule that states that the sum of the angles in any quadrilateral is equal to 360 degrees, and therefore this 4 facing angle must be equal to 90 degrees in its size. So inside the small quadrilateral AP and S, we have 4 right angles. And according to rule 5, any quadrilateral that has 4 right angles must be this rectangle, not a square. So we relate to the small quadrilateral AP and S as a rectangle because it has 4 right angles. But we also know that the opposite sides of rectangle are equal to each other. So in rectangle AP and S, side AP equals to the opposite side NS. But AP is 1, therefore NS must be also equal to 1 unit in its length. Likewise, according to the sum rule, in the sum rectangle AP and S, side AS must be equal to the opposite sides NP. But AS is 3, therefore NP must be also equal to 3 units in its length. What is the length of this missing line segment NO? NO equals to SO minus SN. Again, NO equals to SO minus SN. So NO equals to SO, that is the radius of the circle, that is x, minus NS, that is 1. So in total, NO equals to x minus 1 units in its length. In the next step, we join points P and O together by straight line. PO is the radius of the circle, that is equal to x. So in the next step, I cover this green right triangle P and O in a new page, and we implemented the Pythagoras theorem in this right triangle P and O. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So this is the green right triangle P and O that I covered from the original domain. According to the Pythagoras theorem, in this green right triangle P and O, PO square equals to PN square plus NO square. PO is x, therefore PO square is x squared, it is equals to Pn square. Pn is 3, therefore Pn square is 3 squared, that is 9, plus NO square. NO is x minus 1, therefore NO square is x minus 1 square. So in total, we found out that x squared equals to 9 plus x minus 1 square. So x squared equals to 9 plus x minus 1 square. X minus 1 square equals to x squared plus 1 squared, that is 1, minus 2 times x, minus 2 times x times 1, that is minus 2x. So here we have x from both sides of the equation, so x square we get cancelled. After we cancelled x square, on the side of the equation we left with nothing, that is to say 0. On the other side of the equation we left with 9 plus 1, that is 10, minus 2x. So in total, what we found out, the 0 equals to 10 minus 2x. Here we added 2x to this equation, and finally found out that 2x equals to 10. Here we divided this equation by 2, and finally found out that x equals to 10 over 2, that is 5. for the length of the hypotenuse PO is x, that is 5. X is also the radius of this circle, so the radius of this circle, x equals to 5 units in its length. So our mission is to find out the area of this circle. Actually, the area of any circle equals to pi times the radius of the circle squared, and therefore the area of our circle must be equal to pi times the radius of our circle squared. The radius of our circle x, and therefore the radius squared is x squared. So in total the area of our circle must be equal to pi x squared. But x is 5, therefore x squared is 5 squared. So in total the area of our circle must be equal to pi times 5 squared. 5 squared is 25, so in total this expression equals to 25 pi. So if we found out that the area of this circle equals to either 25 pi square units, so in terms of numbers, the area of this circle equals to 78.54 square units. We finished with the first method. In the next step I presented to you to find out the area of this circle according to the second method. So first of all, we know that all those four angles inside square ABCD are right angles. We define the center of this circle, this point is point O. We define the point of tendency of tangent AS. We define the point of tendency of tangent AB. This is tangent AB with this circle, this point is point S. In the next step, we focus on this convex sum point B. From this convex sum point B, we have two tangents to this circle, tangent BS and tangent BQ. And according to all two, they are equal to each other. That is to say BS equals to BQ according to all two. So if we define the length of this tangent BS as x, then the length of this tangent BQ must be also equal to x because they are equal to each other according to all two. Okay. We know that all the sides of square ABCD are equal to each other. That is to say side AB equals to side BC. Repeat again. In square ABCD, side AB equals to side BC. AB equals to AS plus SB. And AB equals to AS plus SB. It is equals to BC. BC equals to BQ plus QC. Again, BC equals to BQ plus QC. So in total, according to equation 1, we have found out that AS plus SB equals to BQ plus QC. AS is the missing side, so we leave it as it is, plus SB. SB is x, and it is equal to BQ. BQ is x, and QC is 3. So in total, according to equation 1, we have found out that AS plus x equals to x plus 3. Here we substituted x from this equation, so x will get cancelled, and we left only AS that is equal to 3 units in its length. This is 97 AS that is equal to 3 units in its length. In the next step, we extended this 97 AD by straight line until it touches the circle at this point. We define the touching point of the extended 97 AD with this circle. This point is point M. So here, if we focus on this convex sum point A, from this convex sum point A, we have tangent AS, and that is tangent to this circle point S, and from the same convex sum point A, if we draw a straight line, here it will cut the circle at 2 points, point P and point M. In this way, created a chord PM. So all the requirements for rule 10 are satisfied, and therefore according to rule 10, the following equation is true, that AS square equals to AP times AM. Again, AS square equals to AP times AM according to rule 10. And again, if we focus on the convex sum point A, according to rule 10, the following equation is true, that AS square equals to AP times AM. AS is 3, therefore AS square is 3 squared, that is 9. And it is equal to AP. AP is 1 times AM. AM is AP plus PM. AM is AP plus PM. So in total, we found out that 9 equals to AP plus PM. 9 equals to AP plus PM. We can ignore 1 because anything that is multiplied by 1 will not change the value of the expression. So 9 equals to AP plus PM. AP is 1, so 9 equals to AP that is 1 plus PM. Here we substitute 1 from this equation, and we found out that PM equals to 9 minus 1, that is 8. So this is chord PM, that is equal to 8 units in its length. In the next step, we did the construction, that is to say, from this point O, that is the center of the circle, we do perpendicular on chord PM. Again, from point O, that is the center of the circle, we do perpendicular on chord PM. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. When you find the touching point of the perpendicular from point O and chord PM, this point is point N. So here, because of the fact that from the center of the circle, that is point O, we do perpendicular ON on chord PM. So all the requirements of Rule 11 are satisfied, and therefore we can implement the Rule 11. According to Rule 11, perpendicular ON, that is one from the center of the circle, that is to say from point O, on chord PM, will bisect chord PM. Perpendicular ON bisects chord PM. That is to say, perpendicular ON divides chord PM into two halves. Each half equals to PM over 2. So the first half is PN, and it of course equals to the second half, that is NM, and each half equals to PM over 2. So repeat again according to Rule 11. Perpendicular ON bisects chord PM into two halves. Each half equals to PM over 2. So the first half is PN, and it is equals to the second half, that is NM, and each half equals to PM over 2. PM is 8, therefore PM over 2 is 8 over 2, that is 4. From this equation, we derive that Pn equals to 4. Pn equals to 4. This is 9 segment Pn, that equals to 4 units in its length. Our mission is to find out the area of this circle. Actually, the area of any circle equals to pi times the radius of the circle squared. So it is pi, but before that actually, we joined points O and S together by straight line. OS is the radius of this circle. The radius OS is drawn to point S, that is the point of tendency of tangent AB with this circle. Whenever your radius is drawn to the point of tendency, then tangent AB will be perpendicular to the radius SO. If AB is perpendicular to SO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to Rule 1. So by doing this construction, we get the quadrilateral ANOS. Inside this quadrilateral ANOS, we have 1, 2, 3 attacks. The sum of 3 attacks is 270 degrees. So 270 degrees plus the size of this 4 pieces again. In total, they must be equal to 360 degrees according to the rule that states that the sum of the angles in any quadrilateral is equal to 360 degrees. And therefore, this 4 pieces again must be equal to 90 degrees in size. So inside quadrilateral ANOS, we have 4 attacks. And according to Rule 5, any quadrilateral that has 4 integers must be a rectangle if not a square. So we relate to quadrilateral ANOS as a rectangle because it has 4 integers. So quadrilateral ANOS is a rectangle according to Rule 5. But we also know that the opposite sides of a rectangle are equal to each other. So an rectangle ANOS, side AN must be equal to the opposite side OS. But AN in total equals to 1 plus 4, that is 5. Therefore OS must be also equal to 5 units in its length. But OS is the radius of the circle, and therefore the radius of this circle is equal to 5 units in its length. Our mission is to find out the area of any circle, the area of this circle. Our mission is to find out the area of this circle. Actually, the area of any circle equals to pi times the radius of the circle squared. So it is pi. So the area of our circle must be equal to pi times the radius of our circle squared. The radius of our circle is 5, therefore the radius squared is 5 squared. So in total, the area of our circle must be equal to pi times 5 squared. 5 squared is 25, so in total this expression equals to 25 pi. 25 pi is 78.54. So actually we found out in both methods that the area of this circle equals to either 25 pi square units, so in terms of numbers, the area of this circle is equal to 78.54 square units. Okay, thank you very much.